In this video, we're going to continue where we left off in the last video, is how to print out every single element of my linked list. But now we're going to do this using a non-recursive implementation. Another word over here, instead of calling it non-recursive, it is completely equivalent. It's completely equivalent to calling it as an iterative solution. We're going to do something using iterative solution, meaning at some point I'm going to use the idea of a loop. I'm going to use the idea of a loop to formulate my solution here. And what I'm going to do at this point is I'm going to use something what we did in class, which is I'm going to informally invoke the idea of a loop invariant. Okay, so I'm going to talk something about a loop invariant here, and loop invariant. And a loop invariant, as we discussed in class, is something that must be preserved just before the start of my loop, and something that must be preserved just after the next iteration of the loop begins. Okay, so what is the loop invariant I'm going to propose here? So again, I'm just trying to come up with this idea where at the very first try, when I try to formulate my solution, I have it correct. Okay, so let's come up first with a function name here. So I'm going to say def, this is def, and let's call this print fll. So I'm just going to say print fll, but again, this is going to be an iterative solution. Let's just put an I there. Okay, again, it's a really bad function name. This is really bad, but I just want to make sure we have these two side by side so we can see how the recursive differs from the non-recursive there. Okay, what does this taken as an input parameter? As an input parameter, you need at least the head of the linked list to begin with. Okay, so given the head here, my loop invariant is going to say that head at any given time points at that portion of my linked list that is still remaining to be printed. Okay, head points at that node of my linked list which still remains to be printed, meaning whatever is before head, that's all printed. Okay, that I'm just going to assume whatever's before head is all printed. Now, if you don't like to use the head as that as part of my loop invariant, let's just do something slightly different. But I'm going to say, okay, let's just have some kind of a new reference called walk. I'm going to call a new reference called walk here. Okay, and the idea with this new reference walk is that whatever are the nodes that happen to be before walk has all been printed, and whatever walk is pointing at, that node and every single node after that is remaining to be printed. Okay, so if that is my loop invariant, at the very start, what is it that needs to be printed here? Where should walk point at? Walk should point at exactly where head is pointing at, because that node, the first node, is still remaining to be printed. So I can set this point walk equals to head. Okay, walk equals to head, meaning walk at this point is pointing at wherever head is pointing at, which is this first node here. This entire first node is where walk is currently pointing at. And my loop invariant, again, I'm repeating this, my loop invariant is the walk points at that piece of the node that is still remaining to be printed. Every single node after, including walk and after walk, is remaining to be printed. Okay, if that's the loop invariant here, I'm going to say at this point that while walk is not none. Okay, while walk is not none, meaning as long as walk is not pointing at none. Okay, how do I print this out? I'm going to say at this point that print whatever is walk dot element. Okay, meaning walk points at this entire node. From the entire node, I just need the element out. So I can, just to be consistent with my colors here, instead of calling it in blue, let's call this walk dot element. Okay, after I've printed this thing out, I'm going to say that walk should now point at the next node that needs to be printed. So again, my colors, this is my blue, so I'm going to say walk equals to walk dot next. Okay, so let's look at the loop invariant here. The loop invariant at this point, just before the loop just before the loop executes. Okay, just this point over here. Okay, meaning just after this instruction, but before the start of the loop, my loop invariant is that walk should point at that piece of the node that is still remaining to be printed. Every single node after walk, including walk, is the node that remains to be printed. That's my loop invariant. Am I preserving my loop invariant every single time? Okay, so it's preserved right there. The loop invariant is preserved right there. And just after my loop terminates, meaning just at this point here, okay, before the start of the next iteration, I'm saying walk equals to walk.next, meaning I've already printed whatever needs to be printed, meaning I've already printed out one. Walk now equals to walk.next, meaning walk is now pointing at the next node of my linked list. But what is the loop invariant? Loop invariant says that walk should be pointing at that node, which is the node that needs to be printed, and every single node after that. The loop invariant must be preserved at this point, and the loop invariant must be preserved just after the iteration of the loop terminates. Okay, so if you can guarantee a loop invariant preserves at these points here, you will be sure that the solution that you have is going to be correct. Let's just step through this code. Let's just step through this code just to make sure that this actually works correctly. Given this linked list over here, what is head pointing at? Head is pointing at the first node there. I'm saying walk equals to head, meaning walk now points at that node 2. So the condition here is the Boolean expression here is walk is not none. Is walk not none? That is true, meaning walk is pointing at some node there. So this condition is true. I'm going to say print walk.element. Walk.element is 1 here. So what is printed on the screen is 1. Then I'm going to say walk equals to walk.next. Walk at this point points at the second node. It points at the second node. Okay, and my loop invariant gets preserved because wherever walk is pointing is that piece of the node which is still remaining to be printed. That node and every node after that. Okay, the loop runs again. Walk is not none. That's correct. Print walk.element, meaning you print 2. Walk equals to walk.next. Walk now points at the next element, which is this piece over there. Print walk.element, you print 3, then you say walk equals to walk.next. This will now point over there, and likewise this condition is still true, and you're going to say print walk.element, meaning you're going to print 4. 4 gets printed, and then I'm saying walk equals to walk.next. Walk now points at none. Walk now points at none, and at this point when the loop just terminates, is my loop invariant still being preserved? My loop invariant says that every single node before walk has been printed. That is the point when this loop will terminate. Okay, so the moment your Boolean expression becomes false, okay, your loop invariant is still being preserved, telling me that every single element before walk has been printed, and I can see that that is true because I've already printed out every single element of my linked list. Okay, so I hope this was useful in trying to compare and contrast a recursive solution and a non-recursive solution.